everybody, Mrs. Logus here, and I'll be taking you through the last two problems in this review packet, number 16 and 17. So let's get going, shall we? The midpoint of AB is 3, -6. One endpoint of the segment is -1, 2. Find the coordinates of the other endpoint B. So just, as a visual, we have the segment AB. We have that the midpoint, which is not M, in this case it's G, is 3, -6. We have that A is -1, 2, and we know because this is the midpoint that these are two congruent segments, and we're trying to find what the coordinates of the other value are. So I'm going to go about this two ways. I'm going to go about this with the algebraic way, and I'm going to go about this graphically as well. Depends on which one you like more. So let's start with the algebraic way. The midpoint formula is x1 plus x2 divided by 2, or the average of the x's, and the average of the y's. Now the only difference is we're not working with this formula forwards, we're working backwards. So this time we know what the midpoint is, which is 3, -6. So if you add the x values up and divide by 2, it's going to be equal to 3. And if you take the y values and add them up and divide by 2, it's equal to the midpoint y value of -6. So we know that one of the x values is -1. So we could say, replace that with -1. Say -1 plus the second x value over 2 should equal the average of 3. We also could do that with the y's. We have that the y value of one endpoint is 2. So we have 2 plus the second y value divided by 2 has to equal the average or the midpoint of -6, or the y values. So to solve both of these, we would solve them the same way. Both of these we're dividing by 2. I don't want the fraction anymore, so I'd multiply both sides by 2 initially. So over here, the 2's cross out. You have -1 plus the second x equals 6, with the 3 times 2. These pair of 2's cross out. You have 2 plus y, the second y equals -12. Here we'd add the 1. x2 equals 7. Here we'd subtract the 2. The second y equals -14. So I think algebraically that my answer would be 7, -14. Now let's check this in terms of graphing it as well. So this way is much faster, but I think it's more of a check just to make sure you're doing it right. So one endpoint is -1, 2, so -1 up 2. So there's A. The midpoint, which is G, is 3, -6. And we're trying to find the other endpoint here. My suggestion would be think about slopes when you do this. If you're going from A down to G, and this is the midpoint, it looks like we're going down 1, 2, 3, 4, 5, 6, 7, 8 units. We're going over 1, 2, 3, 4. 1, 2, 3, yes. So that means if I continue that pattern, I'd have to go down another 8 units. 1, 2, 3, 4, 5, 6, 7, 8. Over 1, 2, 3, 4. So my point would be here. Now notice that this graph that was provided is not the best one for the situation, which is why the graphing method I think is a fantastic method to solve, but it's not always the most accurate, why it's helpful to know the algebraic way as well. So if we look at this, we said that the point was 7, -14. Looks like we have 7. And it looks like we're about 4 units below here. So graphically, it makes sense that the value of 7, -14 has to be my endpoint B. So that ends number 16. Let's look at the last problem, number 17. Rays AJ, which I'll highlight in red, AJ here. I'm going to make it looking like a ray, and AZ. They trisect segment BC. Trisect means to split into 3 congruent parts. So that means that this segment BC, this entirety of a segment, is split into 3 equal parts. So this segment, and this segment all have to be the same length because these two rays are doing the work, they're doing the chopping, and they're chopping the segment right here and here into 3 equal parts. So symbolism matters when we're looking for this. We're looking for the congruent parts. And the congruent parts are all segments. So we just need to make sure that we are using proper symbolism. So segment B, or let's see, segment CZ, make sure you have the segment symbol. You could either do that, or you could have two little like dots at the end, would be congruent to ZJ, which would also be congruent to JB. You could flip any of these around. You could say this instead. You could say this. You could say this. Any of those are correct, but you need to make sure that all three segments are marked as congruent and that you have the right symbolism of the segment. What won't be accepted on a quiz or a test is if you just do this. To me, I can't tell if that's a line or a ray or a segment, so please make sure to have the correct symbolism. So this will not be accepted. Again, symbolism matters. All right, guys, hope this was helpful. Thank you.